In the previous class, we have seen the problem like this. The same type of problem we are going to discuss today also. Now this is example 1.34 of exercise 1.6 given in the page number 41. In our material, this is problem number 69. Here the problem is investigate for values of lambda and mu. This system of linear equations, these three equations has no solution, a unique solution and an infinite number of solutions. In the previous class, we have discussed the same type of problem. Let us continue with this problem. Again, first you have to write the augmented matrix. The augmented matrix is, just you can write A, B, which is equal to, here first equation 1, 2, 1, 7. Second equation 1, 1, lambda, mu. Then third equation 1, 3, minus 5, 5. Now after this we try to bring this augmented matrix into row echelon form. For that I have to check the first element is 1 or not as 1. Therefore you can make these two elements very easily before that. If these unknowns are there, lambda and mu, and I have to discuss for different types of solutions, means it is better to keep this lambda and mu at the last row. It is better. Therefore we have to interchange these two rows, second row and third row. We are interchanging second row and third row. R2 with R3. We are interchanging these two. Therefore, in the first row as it is 1, 2, 1, 7. The second row, I have write the third row. That is 1, 3, minus 5, 5. Then next one, 1, 1, lambda, mu. Always for this type of problems, try to keep the unknowns at the last row. Now after doing this, we have to make what these things 0 means. Everything is 1, therefore you can directly subtract. Therefore after this, see here, equivalent to, first row you can write as such, R1, 1, 2, 1, 7, 1, 2, 1, 7. Then you can write a second row, R2 gives R2 minus R1. Similarly, R3 gives R3 minus R1. Because all are equal to 1. Therefore, you can write 1 minus 1 gives 0. Then 3 minus 2 gives 1. Then minus 5 minus 1 gives minus 6. Then here 5 minus 7 gives minus 2. Then after that again you are separating first row from the third row. That is 1 minus 1 gives 0. Then 1 minus 2 gives minus 1. Then lambda minus 1. Lambda minus 1. Then mu minus 7. Mu minus 7. Okay. Yes. Then after that we want to make this element as 0 by using the second row. Therefore you can write A, B equivalent to, first two rows you can write as such 1, 2, 1, 7. Then second row 0, 1, minus 6, minus 2. Then third row R3 gives. See here these two are different sign and they have same magnitude. Therefore you can add. You can write R2 plus R3. R3 gives R2 plus R3. If you add these two, 0 plus 0 gives 0. Then plus 1 minus 1 gives 0. Then lambda minus 1. Then minus 6. You can write lambda minus 7. Then here mu minus 9. Mu, we are adding these things. Okay. Then after that, now this is in a row echelon form. The first non-zero entry is 1. Below that all elements are 0. In the second row, this is first non-zero element. Below this all elements are 0 mean you can say it is in echelon form. Now after that we have to find the rank of both A and AB. Yes. Now this is matrix A. Now after that A, this is fully what A, you know, it is in echelon form. Now after this we have to discuss when the system will have no solution. Therefore, first subdivision you can write no solution. See, already I told when the system will have no solution means only if it is inconsistent. We know the system is inconsistent only if rank of A and rank of AB are not equal. Therefore, see here, if this lambda minus 7 equal to 0 and this mu minus 9 is not equal to 0 means this is 0 and this is not equal to 0. If this is 0 means rank of A will be 2. And if it is not equal to 0 means rank of AB will be equal to 3. Therefore, these two ranks are not equal. Hence, we can this system is what inconsistent, has no solution. Therefore, first you can write when lambda minus 7 equal to 0 means lambda equal to 7 and mu not equal to 9. Mu minus 9 not equal to 0 means mu not equal to 9. Then we can say rank of A is equal to, if this is 0 means rank of A will be 2 and rank of AB will be equal to 3. If it is not equal to 0, we have 3 non-zero rows. Therefore, rank of A be equal to 3. From this we can say rank of A is not equal to rank of AB. Therefore, the system is inconsistent. Therefore, the system is inconsistent and has no solution. It has no solution. Now let us discuss the second case, unique solution. Solution means we know very well the rank of A and rank of AB must be equal and they should be equal to number of unknowns. Here number of unknowns is 3. Therefore, both rank of A and rank of AB must be equal to 3 means these things, this lambda minus 7 should not be equal to 0. And this mu minus 9 you do not bother, whether it is 0 or not you do not bother, it can take any value. This should not be equal to 0. If this is not equal to 0, rank of A will be 3, rank of AB is also will be 3. Therefore, we can say these two things, this is not equal to 0 means when lambda not equal to 7 and this mu can take any real number. This mu can take maybe 0 or non-zero, you do not bother, but this should not be equal to 0. Therefore, this lambda should not be equal to 7. Then we can say rank of A is equal to rank of AB is equal to 3. Number of unknowns. Number of unknowns. If both are equal to 3 means and also it is equal to number of unknowns. So we can say the system is consistent and has a unique solution. And it has a unique solution. Thus, now next third one is an infinite number of solutions. Infinite number of solutions. Infinite number of solutions. So, see, when the system will have infinite number of solutions means only if both rank of A and rank of AB should be less than 3. Because the number of unknowns is 3 means both rank of A and AB should be less than 3 means it may be 2 or it may be 1. See, first here only we have unknown, therefore try to make this as 0 and this also 0. If these two things are 0, we will have only 2 non-zero rows in both A and AB, hence rank will be 2. There we can say when lambda equal to 7 and mu equal to 9, then we can say rank of A is equal to rank of AB, which is equal to 2. This is less than number of unknowns. Number of unknowns. Therefore, the system is consistent and has an infinite number of solutions. Okay. Likewise, we will see point 33. Part 2 of exercise 1.6, and in our material is problem 67. Here the problem is find the value of k for which the system of equations have unique solution, more than one solution and a no solution. For these type of discussions, first of all you have to bring this system of equations into row echelon form. Therefore, first we can write the augmented matrix. The augmented matrix AB is given like this. Now here, as I told in the previous problem, in these type of problems, try to keep the unknown values in the last row. But here, this present in every row. Therefore, you do not bother. As usual, you can do it. The first try to make this as one means these two rows can be interchanged. Therefore, you can interchange first row and the third row. Even you can interchange the first row and the second row, nothing wrong. We are interchanging R1 and R3. R1 and R3. Therefore, you can write 1 minus 2 K 1. Then write second row as it is 1 minus 2K. Then 1. This is minus 2. Then K minus 2. Then K minus 1. Then 1, then 1, we can write. Yes. After that, we try to make these two elements 0, means we can use the first row. See here, first row. Can write as such 1 minus 2, this is K, this is 1. Then we can make this second element 0, means you can use R2 gives R2 minus R1, R2 minus 1 minus 1 gives 0. Then minus 2K plus 2. Then you can write 2 minus 2K, 2 minus 2K. That's minus 2K plus 2 you can get. Then you can write as 2 minus 2K. Then here you can write 1 minus K, 1 minus K. Then here minus 2 minus 1 gives minus 3. Minus 2 minus 1 gives minus 3. Then you can go for R3. R3 gives, here R3 is K. Therefore, you can write R3 minus, this should be K, mean this is to be multiplied by K. Therefore, you can write K times R1. K times R1. Therefore, in a rough you write first third row, that is K, then minus 2, then 1, 1. Now, this first row must be multiplied by K. You can write K. This will be minus 2K, and this will be K square, and this will be K. Now, we subtract. K minus K gives 0. Then 2 minus 2 minus of minus 2K. That becomes minus 2 plus 2K. Minus 2 plus 2K. Then 1 minus K square. 1 minus K square. Then you can write 1 minus K. 1 minus K. Now, after that, you have to make this element 0 with the help of previous row. Therefore, again you can write this augmented matrix equivalent form is equal to, write the first row as such 1 minus 2 K 1. 1 minus 2 K 1. Then second also you can write as such 0 2 minus 2k, 2 minus 2k. Third row will be 1 minus element 1 minus k, third element. Then fourth element is minus 3. Now you want to make this element 0 means I have used the previous one. That is, this is minus 2, this is plus 2. If this is plus 2k minus 2k, they have different signs. Therefore, if you add them, this element will become 0. Therefore, you can write here R3 gives R3 plus R2. R3 gives R3 plus R2 you can write. Yes, now if you write like this, 0 plus 0 gives 0. Say by adding plus 2 minus 2 and the minus 2 can also be cancelled, you can get 0. Then here you are adding. Look at here, I will do this rough work. 1 minus k plus 1 minus k square plus 1 minus k square. We are adding these things. Okay. Now if you take this one, write k square first, that is minus k square. For the same time calculating minus k square minus k, then you can get plus 2. Plus 2. If you take minus sign commonly outside, you will be getting k square plus k, then you can write minus 2. K square plus k, then you can write what? Minus 2. Therefore, you want to write, you can write here minus of k square plus k minus 2. Then after that, you will have adding these two. That is 1 minus k minus 3 means minus k minus 2 you will be getting. If you add these two things, getting minus 3 plus 1 minus 2, you can write minus 2 minus k, minus 2 minus k. Since this, all the elements are what? Minus, therefore you can multiply throughout by minus sign. Then you will be getting this equivalent form. C1 minus 2 k1. Then this is 0. If you need, you can take 2 common outside. 2 into, you can write 1 minus k. Then this will be 1 minus k and this will be minus 3. Then if you multiply throughout by minus n, you will be getting 0, 0. This is k square plus k minus 2. If you multiply this minus n, this will be, and this will be 2 plus k. This will be 2 plus. Now see, this is a quadratic form. It is better to factorize. Then only we can discuss these three things. Therefore, this k square plus k minus 2 is like x square plus x minus 2. If you factorize, you can get k plus 2 into k minus 1. K plus 2 into k minus 1. Therefore, this thing can be written here. You can write k plus 2, k plus 2 into k minus 1, k minus 1. Then after here you can write 2 plus k or k plus 2. 2 plus k or k plus 2, both are same. Like, after that. Now it is in row echelon form. See here, under first non-zero entry all are 0. Under the second row, first non-zero entry this one, under this everything is 0. Therefore, we can say it is in echelon form. Therefore, now this is in row echelon form. Therefore, we can discuss this about this no solution, unique solution, and infinitely many solutions. We want to make this no solution means both rank of A and rank of AB are not equal. Therefore, by putting k equal to 1, these elements will become 0 means rank of A will be equal to 1. Definitely, rank of AB is not equal to 1. Therefore, we can say the ranks are not equal. You can say when k equal to 1, rank of A and rank of AB are not equal. Rank of A will be 1 and rank of AB will be 2. Okay, therefore rank of A and rank of AB are not equal. Hence we can say this system is inconsistent and has no solution. Okay, now let us discuss about unique solutions. Unique solution means, as I told them, both rank of A and rank of AB must be equal and equal to the number of unknown. Here we have three unknowns, X, Y, Z, three unknowns we have. Therefore, both the rank must be equal to 3 means this term should not be equal to 0 and this also should not be equal to 0. Therefore, here we have two factors, it is k minus 1 and k plus 2. These two things should not be equal to 0 means we can say k minus 1 is not equal to 0 means we can say when k minus 1 not equal to 0 means k is not equal to 1. K is not equal to 1 and here k plus 2 is not equal to 0 means k is not equal to minus 2 and k is not equal to minus 2. Then we can say rank of A is equal to rank of AB is equal to 3 which is equal to number of unknowns. Which is equal to number of unknowns. Okay, if these two terms are not equal, definitely we will have 3 non-zero rows. Therefore, we can say this system is consistent and has a unique solution. Has a unique solution. Okay. Let us see infinitely many solution. Infinitely many solution means both rank of A and AB should be less than the number of unknowns. Here there are 3 unknowns. Therefore, rank of A and rank of AB must be less than 3 means you try to make this last row 0 means want to make this last row elements 0 means here this is k plus 2 is common. Therefore, if you make k plus 2 as 0, this entire row will be 0. You will be getting 2 non-zeros. Therefore, we can say when k plus 2 equal to 0 means we can say k equal to minus 2. K equal to minus 2. Then this row will become 0. We will be getting only 2 non-zero rows. Therefore, we can say rank of A is equal to rank of AB which is equal to 2 which is less than number of unknowns. Therefore, we can say this system is consistent and has an infinitely many solutions. Infinitely many solutions. Okay. Now let us see the next problem. Number 41 in our material, this is problem number 68. The question is find the condition on these unknowns A, B and C so that these 3 equations has one parameter family of solutions. One parameter family of solutions. See here, one parameter family means that we have to assign one parameter. Here there are 3 variables means we have to assign parameter for only one variable means there are 2 variables left out. Therefore, rank must be equal to 2. Just from this number of variables, you subtract this parameter, number of parameters, then the rank will be that number of remaining variables. See here, 3 minus 1 gives 2. Therefore, rank of AB must be equal to 2. Further, we can break this into row echelon form. First, we can write as H1, 1, 1, A. The second row can be subtracted directly. R2 gives R2 minus R1. 1 minus 1 gives 0. 2 minus 1 gives 1. 3 minus 1 gives 2. Then this is B minus A. Then R3 gives, see this is 3. That is you can write R3 minus. This must be 3 times R1. 3 times R1. Therefore, if you want to multiply by 3 means you can write this is, I will refer here 3, 3, 3, this is 3A. Therefore, you write 3 minus 3 gives 0, 5 minus 3 gives 2, 7 minus 3 gives 4, and C minus 3A. C minus 3A. Now we made. After that, want to make this element as 0. Therefore, we can go for, let me write here itself. First row 1, 1, 1, A. Second row add as such 0, 1, 2, B minus A. That is third row. We want to make this as 0 means we have to use the previous row. That is 1. Therefore, we can write R3 minus 2 times R2. R3 minus 2 times R2. Let me write first R3. R3 is 0. This is 2. This is 4. And this is C minus 3A. Then multiply R2 by 2. This is 0. 2. This is 4. This will be 2B minus 2A. 2B minus 2A. You can write. Now, therefore, after that, we have to subtract. 0 minus 0 gives 0. 2 minus 2 gives 0. 4 minus 4 is also gives 0. Then if you subtract, you can write C minus 3A minus 2B plus 2A you can write. Therefore, you can write C minus A minus 2B. C minus 3A plus A gives minus A, then minus 2B. The last entry will be C minus A, then minus 2B. Minus 2B. Okay. After this, you have to find the condition for the values of A, B, C so that it has one parameter family. One parameter family means I told you must have one 0 row. Therefore, this row must be 0 means it is already row echelon form. Now, this row must be 0 means this value, this C minus A minus 2B must be equal to 0. Therefore, if the system is one parameter family, then we must have one 0 row. Then we must have one 0 row. One 0. Therefore, we can make the last row as 0 means we can say let C minus A minus 2B equal to 0. From this, we can say C equal to A plus 2B. Now, this is the required condition, which is the required condition for the system to be one parameter family. Okay. Likewise, we try to do all this problem. In the next class, we will see the next concept. Till then, we try to revise. Thank you, children.